Mr. T here with a tutorial on inverse trig functions. This is part of a series of lectures on trigonometry for my Algebra 2 course, and today we're talking about inverse trig functions. Before we get into the trig part, let's talk about what inverse functions are. Inverse functions undo another function. So I've shown here a few simple functions. A linear function here, f of x equals 3x. If we want to undo time multiplying by 3, we divide by 3, so this would be our inverse function. If we're squaring, we square root, and we learned in our chapter on exponential and logarithms, to undo a exponential function, we take the log of that base. You may also remember from earlier in the year when we talked about function notation that if we take the inverse function of a function, if those two functions are inverses, we get x, meaning it undoes the function. Pictorially, what we're talking about there, remember when we talked about functions, they're like machines. So we have a machine called f. It has inputs, and frequently in math, input is represented as f, and a function creates an output through some mathematical operation, and in this case the output many times is called y. Now if we have the inverse function, it undoes, so we're taking the output of the original function and treating that as the input, so now we're going to the other direction on our function. So this y becomes the input to here, it's our x, and it generates or undoes the function, so its output is the original input that we started with. So that's what this notation, this composite function notation, is saying. And when we are talking about trig functions, so if this is a trig function, say sine, this would then be sine inverse. Our inputs are angles, and our output is a ratio. So for the inverse trig functions, our input is a ratio, and the output is an angle. And as shown here, if these are our three primary trig functions, the notation for their inverse uses the superscript -1, just like on the function notation. Well, that wouldn't be theta, that's going to be an x, because the input's not an angle. So would be sine inverse of x, cosine inverse of x, and again tangent inverse of x. So our first example will be a right triangle problem. So let me sketch here as best I can a right triangle. And this is, say, angle A, B, and C. And let's say side A is 2 and side B is 4, and we want to solve the triangle, meaning we have to find angle A, angle B, and side C. Now we don't have enough information here. We could find side C by doing the Pythagorean theorem, so that's going to be C squared is going to be 4 squared plus 2 squared, which is 20. So C is going to be the square root of 20, which is 2 radical 5 in radical notation. So we've already found little c. But we don't have enough information here to find the angle. However, we can use the inverse trig function, so let's show how we would figure that out. Let's find angle A, and let's use these two values here. So if we set that up, 2 is opposite and 4 is adjacent. That's the tan function. So the tan of angle A is equal to 2 over 4, which is 1/2. Now we need to solve for A. Now we cannot divide by tan. Tan is not a value. It's a operator. It does something, it acts on angle A. So the way we undo operators is inverse operation. So I need to take the inverse tangent of both sides of the equation. I simplified the 2/4. Now, from our definition of inverse function notation, if you take the inverse of a function, you get the input. So the inverse here is going to be just angle A. And now let me pull a calculator over. And make sure your calculator is in the right mode, so verify this in degree mode. And now we can calculate the inverse tan. Those are in yellow, so we need to use the second button. And we can input here 1/2 or 0.5. And we get, we'll round that so we get 26.6 degrees. Now we can find angle B. We could use another inverse trig function, but we know these two angles add to 90, so angle B is going to be 90 degrees minus 26.6 degrees, which is 63.4 degrees for angle B. So now we have found B, A, and C for our problem.